Okay, hello everyone. Welcome to another Wolfram Language Design Review for version 15. And we're looking at discrete computation. So, graph value plot. Didn't we put in graph value plot? Wasn't that in 14.3? Or is it not? Has it never been seen? Guys?
No.
Can you answer, please? Always helps when you actually say something. So this is completely new to this version. I'm just remembering it from a couple of months ago.
Yeah, it's
Is
yes, it's
something
new.
wrong? Okay,
Oh,
then.
yeah, sorry, I just said. Yeah, we went through that during the review, probably that's why.
Preview.
Review.
I mean, this should just be a function, right? I mean, it's amusing to put these properties, but I don't think that's what I want 99% of the time. I'm trying to plot a function, which I can do by saying, you know, a vertex style arrow, blah, 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 blah. What is this plotting? How is this plotting things?
So
Do you understand my-
It's deriving a quantitative value associated per vertex, per edge.
I understand that, but I think it should just be a function here.
I think there should be a fun case for sure.
right, you will take a function. So what we thought about is, the most easy case. That's what we call prop. It can be a property, right? So in several cases, people have a numerical quantity, right? Even the function evaluates a numerical quantity, and this kind of what.
No, I understand, but the problem is that eigenvector centrality is global to the graph, and this is then applied locally. And so what one needs, this is like a graph evaluation thing, where the function needs to apply to the graph, derive a value for each node, and then this is going to visualize that value, right? And it seems like there's a separate thing which could add an annotation to each node, which is some value of some function as a function of the graph.
I mean, these are just things that are exactly what you say. They compute this one, eigenvector centrality, for instance, is something per node.
No, it isn't. It requires knowledge of the neighborhood of the graph.
Yes, but the value is per node.
I understand that. I understand. So it's a painting of the graph based on some potentially quite global properties of the graph.
Yeah.
And then, to me, look, there's one thing, which is plot a function over a graph, right? In other words, like, let's say I have a
but we said
mapping.
that's going to be there, okay? We already covered that.
No. I'm making a different point.
Okay.
Look, if I have a graph, there's several things I've done this many times. Okay. We could find many examples of graphs where I've done this.
And we have done it many times too. We can find many examples, application examples where this is done.
Okay, well, let's take a look at a few. Let's see what I've got here. That's not really values on the graph. Let's take a look. I'm sure we've got some good values on graphs. This one might have some. That's not really values on the graph. That's really annotating some nodes, but not others.
Yeah, but that's more like labeling.
It's more like labeling, yes. Probably likewise that one.
It's more like a quantitative thing. How do you map quantitative stuff?
Yeah, I got it. So let's take a look, because I've definitely done things like that. That's an example.
Yes. What are they?
I'm trying. They're weights that come from. Well, we can look at the code.
Yeah, I mean, but that's. I mean, your average student and user is not going to want a weighted branchial something or other. But that's the function case, so that's perfectly fine.
No, I'm not so convinced. Hold on a second. I mean, there's several different things that I've done many times. One is to say something which is easy to do with vertex style, or let me find another example. So that's one example. Let me find another one because I think I remember some other good examples of this.
So, I mean, let me enumerate a few obvious use cases then. So
Mhm.
when you solve flow problems, so then you have edge capacities and sometimes
Yep,
vertex capacities. You want to know
yep,
them.
yep, yep.
You want to know what the actual resulting flow is going to be. So you want to show that on the flow graph.
Right. I found another example here. So this is one very much like what you're saying.
Mhm,
Those actually no, the sizes in this case are just local properties of the vertex.
mhm.
In other words, the size
I
is
mean, it doesn't
determined.
matter how you compute it. The thing
So
is that you have a
Well, it
value.
does because we have to know whether the function is a function of the vertex name or something completely
right.
different.
So it's actually what this function is resolving. So you have first the vertex and the edge, and now you have the corresponding encoding, which can be size, color, shape, right?
Okay.
So what we try to do with this function is to flow all that. So if you look at the second specification in the
Okay.
usage, it's actually the most general one with association, where you can say W can be a vertex or an edge, and then you specify the encoding, right, which correspond to a specific value. So here we just use val, we haven't used a function. We can definitely add the support of a function if needed.
Okay.
But at the
Hold on.
end, you have a
Let's just take a look at this. So
This is like point value plot, in the sense that you could have vector values. I don't know that there are vector encodings here yet, but you could in the
not yet.
future.
Right.
Okay.
have you looked at what's done in the hypergraph packlet? Because I think we've had the same issue there. I don't know what's been done. I think you should take a look. There's
Okay.
some annotation set up there. Um, Let me just say, I'm not a big believer in these. This is a very specialized kind of, yes, it's in courses and things like that case. This is more real as far as I'm concerned. See what I'm saying?
Yeah. I mean, I think these enumerate cases where we had to write this function specifically for the application pages, a special case of this function repeatedly all the time in order to.
No, I understand that. But wouldn't it be nicer if this wasn't a string, but it was actually somehow, it's like handler functions, okay?
Mhm.
Where it's like, what do you feed the thing, right?
Yeah,
And
I'm not saying
and
you're wrong, Stephen. It's
So,
the thing we need to know is like if there is a function like centrality, vertex-oriented centrality, we need to know it gets a vector back. I don't think it gets sort of association back. And so you need to know that it's vertex-oriented stuff.
okay, let
And
me make a suggestion. Okay. What would happen if we use our modern associational stuff and we could do things like we do with videos, hash vertex, hash, whatever it is, these names, right? Hash edges or something like that. Because like we do with video, when we process video, we use these things, it's really quite convenient.
Mhm.
And then what we could expect to do is, we could just say hash graph. I mean, okay,
What are you talking about
it's,
now? Forgive me. Let's back up.
I'm talking about saying graph value plot of graph, comma, and then something like um uh well something where we say, log of hash vertex, where hash vertex is that's probably a bad name, but I mean in that could be that's not the right kind of thing. I mean something like hash vertex um some function of the name of the vertex is what you use to make this plot.
but then your function also need to be
I know,
associated to a result.
I, I know, I know, I know. So, for example, in the case of hash graph, it's much less clear how that works because you have to gulp in the whole graph and get every vertex's result from that graph.
Yeah.
Right? Okay,
Yes.
let's remind ourselves how point value plot works, which I have really not had a chance to use. I should have used it because there are cases where I really needed it.
Mm-hmm.
See, that's interesting. We just say it's a point and it's a value.
Right.
And in a graph, in the end,
we have vertices and edges.
I understand that. But in the end, a graph, so suggestion, okay? So in a graph, what do we have? We have graph of vertices, comma, edges. That's a form of representation of the graph, right?
Mm-hmm.
So I just wonder if the full form of this becomes vert1 goes to blah, 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 blah. I mean, the fact is, we could disambiguate edges and vertices because edges always have a head that is, directed edge or whatever else.
Right.
But I'm not sure we want to do it that way. But then, and then maybe arguably there are edge goes to whatever. I don't like that very much. I think that's not the right way to do it. But where the full form doesn't have this kind of telling jokes by numbers aspect of having these very specific things built in, but has the feature, if we can do it, that the full form just does this, which,
But
yes, go ahead.
Is what's happening in the second case, as I said at the beginning. So this string form is just an easy standard example we try to emphasize. The second case, the val, right? So the W is your vertex or your edge, right? And then you can just, instead of the association, you can give a specific value like in your examples.
Then this is the form that should be documented first.
Okay, we can do that.
Vertices and edges, and you're using the fact that an edge is determinable by the fact that it has, that it looks like this, right?
Yeah,
Yes.
directed edge, undirected edge, or yeah.
Now, what happens what's the precedence if you say AROB, ROC?
Don't know.
It's wrong.
Right.
So you got to have some examples that show that correct. Okay. Is it the case that in setting up a graph, I can say this?
No.
No.
I mean,
But it's a bit inconsistent to be able to do that for graph value plot and not for graph.
no. I mean, we absolutely. You have the graph given there. When you specify a graph, we can have a graph with edges with vertices that have no edges.
Yeah.
And we need to
I
be
understand that completely, but I'm just saying syntactically, if you're mixing vertex specification and edge specification here.
Yes, it's a bit.
No, but in the case of graph value plus, there is a rule, right? You left-hand side assigned to the right-hand side. So,
I mean, the graph specifies what
point.
the set of possible vertices and the set of possible edges.
Yes, as two separate arguments.
No, but they're in the graph. They're in that object. Whether, it's not argument or anything. They're in there.
Good point. That's a good point. I agree. Okay, that sells me. Is there a form that one should be able to give that is merely, V1, V2, V3 positionally?
No.
The second argument.
What do you mean by that?
Red, green, blue, something like that. First vertex is red.
I think highlight graph is doing that. This is the quantitative sort of case. The value, there's a quantitative value.
Fair point. Well, okay, fair enough. But you could imagine values for every vertex. But okay, I'm conceding on that.
Right. That's what we couldn't get into highlight graph. We tried many ways, many times, and it just does not make
the quantitative thing.
Yeah, the quantitative thing.
Okay, so let's take a look here. I don't understand how this works. This syntax is pretty incomprehensible to me.
It just says that you're gonna, so you can map it to different graphical dimensions. And so let's look at what they are. If we go, yeah, you can look at the sample too. This is a color encoding. The second, there's a size encoding, there's a color encoding, and there's a label encoding.
Okay, look, let me make a meta point. I do not think this is fully cooked. This is going to take us a little while to cook here. We might want to go on and look at some more of the agenda and come back to this.
Sure.
Let me just think for a second. I'm just not getting this. I'm sorry. You know, this is, you're saying, what the heck is that doing? I mean, this is saying vertex size of vertices should be encoded by this closeness centrality. Presumably, closeness centrality of a graph is that thing, closeness centrality of that graph is a list. What the hell that is? Well, whatever. Okay, it's just a list of values, right?
Yes.
And so my comment about this list of values is not totally stupid, right? To be able to say graph value plot and give a graph and then just a list of values, one for each vertex, is not stupid.
To as a default case to take them to be vertices, or what?
No,
yes,
so
absolutely.
There is several efficient way, right? You don't always want to represent the encoding and the value every time one. So if you have a really big graph, right, 10,000 elements, that would be expensive. So there are several shortcuts we did where you have several value like that, where if you just say the vertex size goes to the following, then we know that you are mapping it to every single vertex. So it's kind of what essentially it does.
Look, this is pretty muddled, okay?
It's syntax stuff we're talking about here, right? And not the functionality.
Yeah. Right. No, the functionality is fine. Okay, look, I think this should work. Okay, I think this should do a good default thing.
Right, okay. But we decided, and I will say, we thought about this case and they decided not to support it because you don't know if it's applied to a vertex or an edge.
Yeah, but you can figure it out, and we can default to vertices. That's a perfectly reasonable thing because the vertices have a very definite order. The edges do not.
Then the edges,
what's that?
No problem. Yeah, we can support
that.
But
I mean, but then the question is, what does this graphically do? And that's a good question. And, you know, I think we have a certain degree of freedom. Like if these are very exponentially different in size, we might want to do some logarithmic thing. I think we can be clever here. See what I'm saying? Not just a linear mapping of size.
Yes.
And if it is a linear map, you know, we also don't want things.
No, I mean, we've learned that. Like vector plots, it's very important. You know, that's why vector plots generation 1 did not work. They were trying to map it to size, linear size. Does not work.
Right. And nobody expects it. I mean, it's not like one's going to get out a measuring tape and say how big is each vertex. It's a question of, you know, what are the important ones? What are not the important ones?
Yeah, it's like a relative. It's a relative.
Yeah, it's like word clouds do the same thing. They're not, you know. So anyway, okay. So this is the minimal case.
Well, one can also, and I think we need to do that, probably develop a type of legend. And there can be a nonlinear scale for size or whatnot.
Right. So another case here is surely this goes to styling of some kind. And I could imagine, but I don't know how to specify this. I mean, you know, it could be vertex size, it could be vertex color, or just color or something. I don't know. I don't know how to represent that.
I mean, it's.
Go ahead.
I mean, from our Roger example, you just flip. All we say is vertex size goes to those values. right? In your case, you want the value goes to
I'm
the
not sure
study.
I'm not sure what's right. Okay.
Yeah.
But what if you want both color? Okay, so let's take the next case. I've got two values for each vertex. One is going to encode color and one is going to encode size. Do you have a syntax for that?
That's basically
Right.
vector valued.
Well, but
So,
go ahead.
so from the original specification,
By the way,
right? So,
is Brett not here? I mean, is Brett not involved with this?
No.
Okay.
so
Sorry. Go,
for the original from the original specification, you will say vertex one goes to vertex color, and then you specify the color, and the vertex size, you specify the size or whatever type of encoding you want, right? And so that
Oh, but
defines,
that means that you can repeat the vertex twice.
you can do whatever you want because you get the full specification.
I mean, right, because you can, let's say vertex one is encoding one, value one. Vertex one is encoding two, value two. Is that
Or
doable?
you
Do you have an example of that? I mean, that is doable. If I
no
read the
no
spec there.
you see the second side, W1 can be the vertex, the encoding, right? Can be vertex color, vertex size, goes to a value. It's an
okay.
association.
Look. I think that reusing these options would be a good thing, rather than having 16 other random jokes by numbers type things here.
So it's not just that, right? So because you have to make a distinction between, quantitative and categorical value, right? Like if you want to specify shape and somebody gives you a list of values, right? Are they discrete or are they continuous? So there is all that distinction we wanted to make, right? So
by the
that's why
way, I think also, which we learned this lesson over and over again, which is I think it's probably really good to categorize when you have quantitative value, because to visually perceive a continuous
Sure.
variation is incredibly hard.
Yeah, no, I agree.
And if you bin it to five values or some small number, it's probably all you need in
Okay,
many.
let me make a general comment. I think this function is developing, it is an expanding Swiss Army knife.
Yeah. Yeah, the
And
thing is that it can expand on encodings,
I know, but I'm not sure that having this one function that does all these Swiss Army knife of things is the right thing. I think it may just be incomprehensible. Options upon options. I think it reminds me of plot layout, which I think is horrible, and which is just starts falling over because it's like, oh, I've got a string that means this, but then what happens if you want that option as well? I think this needs, I would argue this is an important piece of functionality. It would not be the end of the world if we had three functions that do things like this, rather than trying to shoehorn everything into one function with lots of tentacular options that aren't particularly flexible. So I just think we need to define, okay, so you're defining there are several layers to what's happening here, right? There's two each. Okay, what are we trying to do? Two each to each vertex or edge.
So we have several graphical dimensions for each.
Yes, I know.
And it can be expanded in the future.
Right. We want to associate a number or a list of numbers or categories, etc. We want to associate an expression. Okay. And then we want to render. Okay, that's stage one. Okay.
No.
Stage two is we want to render the expression from each vertex or edge. So I'm going to make another comment. Right now we have the not very easy to use vertex shape function. Okay. Whatever it is this function does that goes from an expression to the rendering, it should be possible to say, whatever it is, I'm going to make it up, right? Vertex rendering style goes to function that, or a thing that works the same way this works and just put that in the graph. Do you see what I'm saying? Whatever function goes from the expression, for each. Okay.
I mean, we got to go back. I mean, most of these other things are local. Like a vertex rendering function is local.
It is, but the whole point is
but here we need. I mean, it's doable.
No,
I'm just saying
I
what
think
the
it's the wrong
difficulty
thing
is.
to do it in one function. Okay, so I think that what you're talking about is step one. Step one, to each vertex or edge associate a number. Okay, so let's imagine that we said something like graph apply, making it up. Okay, between this centrality. Okay, to G. And that what that did was it associated with every vertex in the graph some annotation that is that value. And then the second step would be, graph value plot or something. That in other words, what that does is it puts values on every node. It puts a value annotation on every node, and this picks up the value annotation and uses some styling to render it.
Yeah, it's a possibility.
Yes, so can I add something, right? It's actually what is happening now. It's just that, unfortunately, in this documentation, I use the string between the centrality.
No, Charles, it's not right.
No,
it's not right. I'm saying we should have two functions.
Agree. We don't have the graph apply one. I'm just saying the graph value plot is exactly what you are describing.
Okay, good. I'm not surprised. Right. So what property, what annotation is it picking up?
So the graph value plot, the idea is quite simple. You have a vertex or an edge, right? You say, I want to associate a property. So, and the property can be the size, the shape, the color, to the following value.
I understand. Right? But so a default thing we could do is this, suggestion, okay? I mean, it could even say, annotate graph, perhaps. I don't know whether it's graph annotate, whatever it is. Okay, let's imagine it was graph annotate. Okay, and this is the function. And I could imagine, well, now how do we say whether it's annotating edges? I mean, we could even say, because it has to know whether, I mean, we could even say graph vertex apply. Okay, suggestion. Graph vertex apply, graph edge apply. Function, okay? And then what this does, function to graph, and then an optional argument that gives what the annotation is that you're adding. Okay, the default will be value or something like that.
This actually reminds me of transform columns.
Yeah. Yeah. It's a good point.
Where we kind of add new columns, right? By giving it just a name and an arrow and then a function.
Yeah, that's a good idea. Right. So maybe we want to say, I mean, the bad name, but graph add annotation. And then we say graph F anno an1 arrow F1.
Right. But we still need to know whether how do we know whether it's edges or vertices?
I don't think we do. And I think we have to, that's why I think we should have two functions.
Yeah.
Because I think conceptually, this will be the most common one, I suspect, but conceptually both are relevant.
Right.
And in the edge apply thing, fundamentally, you probably want to just give two arguments to, well, I don't know, you probably want to give the edge because you need to know whether it's directed or undirected and so on. But that's going to be a little awkward. But let's imagine it's graph vertex apply, graph edge apply. It produces an annotated graph value plot simply, and then here, if we say, I mean, we have a notion of a vertex weight, don't we? We certainly have an edge weight, right?
Yeah.
Yes,
we have vertex weights too, and capacities in both too.
Right. So this second argument, if you just said here, edge weight.
Yeah, that's an annotation. Is what you're
Right.
saying.
And then that annotation would just be, that would be what would render. And you
Mhm.
know what it is annotating because you can see in the graph, let's say you had an edge weight annotation that was annotating vertices as well as edges, well, then it would do both. But otherwise, it knows what it's annotating. So let's just go through, in this picture. Go ahead.
I
And I
think
say,
what Charles
and I
did
say, it's correct, and it's actually what graph value plot now is doing with annotate, right? It take annotations, right? So the part which is missing, you are pointing out, I believe, is the graph apply, right, where you actually build new annotation,
Yes.
right?
Yes.
So it's that part we are missing now,
Right. And
we
that's
can
why I'm
definitely
saying
add
that
that.
I think that graph value plot should be much dumber. It shouldn't actually do anything. It should just render.
Yeah,
But
sure,
it
we
needs,
can.
but it still needs to know about different encoding styles. I think that,
Absolutely. Yes, it does.
you
But it
know,
does
And
not need, that's a rendering issue. And let's talk about how we do that. Okay, so
yeah, I mean, yeah, it's
okay.
it's a bit tricky to do
Well,
them right.
let's talk about it. Okay.
Mhm. Let's talk
The,
about it.
right. So let's assume we have graph vertex apply, graph edge apply. Okay. Not sure if that's quite the right name, but let's assume it is. It's got these annotations, it's got a collection of annotations. Knowing what annotation you're looking for. Okay, so hold on a second. Graph value plot would have another syntax, which is just, okay, so which would be the values, the vertex values. Or it could probably have an association thing where it says something like vertex values, and I know this is getting quite close to your design. Vertex values is blah, edge values is blah. Well, I don't know how edge values works. I mean, edge values is going to be much messier
I mean,
because,
there's a linear order to them too. They're well
all right,
defined.
fine. Okay. So now that has defined, so we're either just naming an annotation, or we're doing this. We are not trying to put that function, the function that generates these values, we're not trying to put that into graph value plots.
No, I
That's in a
think that's
separate
fine.
function.
I mean, I think that's fine. It's a nice separation. And it's not
Okay.
very hard. It's a short step to do it. It's not a
Yeah,
big deal.
right. Okay. So then, okay, so now the question is,
But then prop is an annotations, right?
for what?
For the values. Your edge weight is an annotation.
Yes, that's right. That's an annotation, an anno.
An anno.
But the question is, how are you going to do with, maybe you want to make several annotations, not just one.
Fine. In that case, you give a list of annotations here, and now we have to decide how to render them, right? That's a different issue. I mean, these vertex values could be lists, for example. Okay. Now the question is, so let's imagine that a vertex value is a list. Okay. What are we going to do to render it? So one possibility is, so there what we need is a rendering function that could take the first element of the list, make it size, the second element, make it color, let's say. Right? So what we have coming in, and I'm going to claim that whatever that story is, we should have an option directly in graph that does that, like vertex rendering style. So, okay, here's my suggestion, I think. What can we do with a vertex? We can style it, we can size it, we can give a label to it.
I mean, we could do many more things. So you can have like a little bar chart there,
Right. So
a pie chart, you know.
Well, right, but that's a vertex. What that
it,
is
But,
something
but
which we should have had, which is essentially just a vertex appearance, but we've got vertex shape functions.
everything vertex appearance is sort of finite enumeration. It's not very flexible. It's just
No. I'm not suggesting it that way. I'm suggesting that you should be able to have, I mean, right now, when I put vertex shape functions in, it's a pain in the neck. right?
But they're very flexible.
I know they're flexible, but I'm saying you want a bar chart at every node. You
Mhm.
can obviously do that with vertex shape function. If you want an easier way to have a bar chart at every node, we have to have another option to do that.
Right.
Okay. But now, okay. So now the question is,
Didn't you have a case
But
where you had
we have a vertex shape, right? I mean, am I confused? Maybe I'm missing a point here, but
no, I
for
mean, if
some
you go,
reason, vertex shape is never useful to me.
no, we could, vertex shape is, if you have categorical stuff, you could vary sort of a finite enumeration thing. But if it's something quantitative you map, you need to sort of do the mapping from the quantity to the, to the,
Yeah, this is not, this just doesn't make sense, right? This just, I don't think, well, okay, maybe the examples are so bad that I can't tell what the heck's going on. Because let's do an example here. Let's say we say, complete graph 5 vertex shape goes to X blank goes to pie chart of random real 1, 3. Okay.
vertex size.
Okay. I hope you can do this performance goal thing automatically.
Yeah, this should be fixed.
Well, it isn't fixed here, and that still didn't work.
We fixed that, and there's an inconsistency. It's during the process. That's why it's breaking. So
I see.
fix that.
Look, I admit I haven't. Okay. I didn't understand that. Okay. When I saw this, I mean, maybe I'm just kind of being stupid about it, but this is very badly documented. Like this, for example, the fact you can have a function there, not documented here, is it? No documentation of that. This is really bad. There's no documentation, and this is imagining some use case which is completely not the use
Yes,
case
it's
that anybody
okay.
has.
Yes, it's not a great documentation. The use case is there. We wrote it 10 years ago. I always repeat that. Yes, it's not that great in 20 years
Right.
after.
Okay,
The last line, we have the rule, which say V1 goes to G2.
yeah, but that's not this. That's not this.
And I agree, we cannot write all the cases.
No,
We
I
will
know,
add
but
it.
this particular case is obviously an important case because it allows you to apply a function to the vertex, to the, now here, I don't even know whether that's a vertex name there, right?
Yes.
Is there an edge shape option?
No.
Okay.
And
Can I
I agree
suggest that you feed this to Eric and Jeff in the under documentation project so they can fix this?
yes.
Okay. So at least this isn't, I mean, I could have used this a zillion times. I've written custom vertex shape function. And by the way, let's take a look. Oh, come on. What's the excuse here? Why doesn't this point to vertex shape?
We missed that. We'll fix that.
It will be good to have a note in vertex shape function that says basically, this allows you to get access to more detail than vertex shape.
Yes. Yep. The why, you mean? The motivation. Yep.
Yeah. I mean, and then from vertex shape, you say, you want more detail, go to vertex shape function.
Yep. Good point. Absolutely.
But I mean, I think that the main
It's a hierarchy
documentation,
of simplicity. Yeah.
right? The main documentation here has nothing to do with, use the vertex name. Well, I don't even know what that means. I mean, that's just incredibly obscure. I mean, the main thing, and this is useless as well. That's not what people want. That's amusing and decorative, but it's not what people want. They want to put information into every vertex. Anyway, okay, we'll fix this.
Yeah.
I mean, it's not like I haven't pointed this out before, but anyway, we'll fix it now. Okay, and I'm glad this works. It's nice. I hate to think what would happen if things weren't circular, but that's a different issue. Okay, so I still now want to understand, in a world where there is a vertex shape specification, well, you're saying, how do I render 6, 4? Okay, I want to go from the vertex value, right?
So,
What is
okay, so just a meta point here. One of the things, kind of like these multi-panel things, what is it that you want to be able to compare? So, like say, I have a bunch of edges. I want to compare this attribute or this property or this quantitative thing between the edges, right?
yes?
So I need to globally know things.
I agree.
Otherwise I can't compare.
It's like color function scaling and things like that.
Exactly like that. Exactly like that. Yep.
Right. So, that is the problem we're trying to solve. Vertex value goes to rendering.
Mhm.
And I suspect we can use a lot of the things we've already used in, in standard visualization, like color function scaling. Let's think about this. So we got a collection of vertex values and we want to find a rendering for all of them.
Yeah.
Which is very similar to, I mean, how does this relate to multidimensional plotting this is why I think Brett should be involved in this discussion, because we've already invented a bunch of ways to do that kind of association of, multiple elements here with multiple rendering things. Like, for example, in a bubble chart, is it not the case that you can do size and color separately?
No.
I thought you could.
Actually, you probably can, but we don't promote it because the way we give data is, the
Oh,
basically
this is multiple data sets, right?
yeah, multiple data sets is what we use it for.
Okay. But fundamentally, we've got all these things. We've got color, size, shape, and we could do the same thing for bubble chart. I mean, bubble chart could in principle have a shape.
Yeah.
Can I suggest, okay, we could try and get Brett now. I think we're running out of time. I'd like to go through the rest of this agenda. Let's
Yeah.
loop back to this.
I mean, I'm going to
some
have to
ideas.
leave pretty soon anyway, so it's. Yeah.
Do you want me to ping Brett or?
No, not
okay.
now. We're going to have to do another meeting.
Okay.
I mean, this direction of utilizing a richer higher dimensional graphic space to encode things, you'll see that pop up in lots of places.
I know. So let's not jump the gun here and do something that we'll regret.
Right.
So I do think that, think through this graph vertex apply, graph edge apply, because I think that's a pretty decent idea. That then, and then what we could do is initially expect to have some kind of function. We can have some defaults here for how these get rendered, like we do in a highlight graph.
Yep.
And then have some function that just says, take this and render it as blah. And I could imagine something where,
the thing is that
vertex,
when okay, so usually the big problem with that is that we don't get the global picture.
I know that. So that's why, I think we have this issue. I don't know what we do for video and things like this, but basically we need both this vertex and all vertices, but we need to compute the all vertices thing once.
Yeah.
I mean, that's the problem. The problem is, I mean, we've also got problems that are very much like plot range arrow automatic, right? The analog of that.
Yeah. I mean, if you have outlier scales, how do you do that? And this was the problem with vector plot, because there's a glyph oriented thing there too, right?
So how do we solve it there?
So initially we solved it by trying to do logarithmic scaling. It became better, but it's fundamentally, it still doesn't work for the length. So what we solved it then was to do, so we have orientation. Orientation is always there. The size, the length is fixed, but we map it to color. We encode it on color. That means that when you have extreme values, small or large, they're going to wash out. But that's probably okay. That's probably the correct thing to do to understand the
Yeah.
vector field. So
Yeah.
what it means is that they have more or less 100% success rate now when you plot them, whereas before they had, like a 10% success rate. And you
No,
had to,
I agree. I agree. It's been a success. I
right.
mean, I think that this stuff here also deeply relates to graph evaluation. Where are we at with thinking through graph evaluation?
What do you mean by that?
I mean, like a DAG, and every node has, I mean, like the things that Brad wrote, for example, every node has a function, and you're rippling through the graph and evaluating a function.
I think we're going to have to look. I don't
It's
know.
not, yeah,
I don't
it's
know.
not for this release. This
No, I know it's not for this release. I know that,
What?
but I'm
Yeah.
saying that
we,
once you get those values, whatever we do to encode those values when we evaluate a graph, right? Whatever we do to encode those values, you should be able to just say graph value plot of that graph after it's been evaluated and plot those values. See what I'm saying? So whatever mechanism we have for graph vertex supply, all those kinds of things, graph vertex supply is a local applier of, a function applied to every vertex, right?
Is that
Not
what you mean?
right. So, I mean, in principle, this graph value plus does that. That's why it have that annotation as long as you can access or refer to those value. Yes, it
what?
has that.
Actually, it's not what I mean. Graph vertex supply, I'm imagining that you're going to get a list out of all the function f is going to give a list of the vertex values. That's what you're really going to do there, right? Like the betweenness centrality. So this
But those are
turns.
global. Those are not
I,
local.
I know. So what I'm saying is you apply f of graph, right? That gives you a list of values,
Mhm.
and then you're threading, thread values into vertices. See what I'm saying? Of this, right? That's what this is doing. That's saying use betweenness centrality, get a value for every vertex with betweenness centrality, and then put those values into the individual vertices.
Yeah. But I thought that that's what we did for the graph annotation. Well, maybe that was just an alternative to that. I don't know.
I don't know. What
No,
do
it's
we
what
do?
he did.
What you did down there. You wrote graph add annotation, graph, comma,
Oh
and
yeah,
one.
that's an alternative. Yes. Yes, that's an alternative. Right. That's an alternative. I don't know what the right way to do this is.
Mhm.
I think we are going to need vertex and edge apply. So that's why I think it's going to get rather messy with this. But guys, can you think
But then,
about
yeah, we will. But in terms of workflow, get stuff into the graph, pick stuff up from within the graph is the basic workflow that we're talking about.
Yes. And then pick stuff up, either functions that extract that from the graph, like annotation
So I
value.
think that there will be good, I think that there are other good things for this, because you can probably pick up those values in other functions, styling functions and other things later
Yeah,
on.
right. Right.
So
But I think exactly. And so, just so I understand, there's annotation value, which I think pulls annotations out of a graph, right? Is that correct?
Yes.
So what we need is put annotations into the graph, pull annotations out of the graph, and then render those annotations.
Well, so we currently have that framework in place. It's just like you say, we want to apply, right? We have set, annotation value, we have annotate, we have annotation delete, right? But in this case, you just want one where you apply the F and apply the annotation all at once, right? So we can add that and then read those
But these
annotations.
annotate things are one node at a time, right?
Right. And there is no function per se to apply. Yes, exactly.
Right. Well, maybe we need something which is an annotation apply that does, that with a function that we could use in other places as well.
I'll be right back.
Yep.
Annotation apply F to graph. And then what the annotation is supposed to be, the anno name. Or possibly, annotation apply, and the default is value or something, and then anno arrow F to graph. See what I'm saying?
Yes. Yep.
This may be the right approach.
Yeah, I think we just need to extend the whole annotation functionality and language.
Right, but then once we've got that, then graph value plot is either given explicit values that it's going to plot on the graph, or it is given an annotation name that it's going to pick up to plot on the graph. Do we agree?
Yep. Yes.
Okay. Then the issue is once it picks up its vector of values, whatever that is. So for example, we might say that you want both edge weight and foo picked up here, right? And that would then give a list of values for every node of every edge of the graph, let's say. Well, I don't know how we say its edges, but that's a different issue. Maybe we do that in vertex values, edge values, and then we say edge values goes to, well, it's not going to work because it's ambiguous syntax. But anyway, okay, we're dealing with that, edge annotations, arrow, whatever. So I'm saying where that then becomes.
No, but I think generally the base idea that you have is like stick the actual values in the graph.
Yep.
Pick up the values from within the graph.
Yep.
That workflow is ultimately going to lead to tighter and shorter workflows, potentially in many places.
Okay, but there's one more piece to this, which is once you pick the stuff up from the graph, let's assume from every node or edge, you have a vector of values. Those values might be integers, they might be this, they might be that, right?
Right.
And in general, what you have is a list of lists of those things, right? Because it's for every node of the graph, you have one of those vectors. The global thing is just that list, right?
Right.
So then the question would be, if you were taking that list and plotting it in our normal plotting functions, just how would you represent those numbers?
I think it strongly depends on how many there are. If there are like 1,000 numbers, probably list line plot.
Yeah.
If
okay.
if there are like 5 numbers, maybe a bar chart.
So okay, here's the point, Roger. The thing that's interesting here is normally we have something like coordinate. If we're doing something like with point value plots, it's coordinate arrow value, right? That's our normal plotting. Here, there are no coordinates. The coordinates are automatic. See what I'm saying? So then the question is then, what do we do? I mean, point value plot doesn't have auto scaling, does it?
I think it does. I think it
Well,
does. Otherwise, it can't
I think
really.
it doesn't, because I think it just gives, I think all it's doing is it gives the value styled according to those values. So how do I get those little pie charts?
You're scrolling a little faster. Well, that was in the case that you see there. That was an automatic choice. It wasn't.
Okay.
You didn't pick it.
Okay. So I mean, that's the thing. We could do the exact same thing.
So you can see the next one has size as the encoding.
Right. So I'm suggesting, what about the exact same thing? If you have a vector of values here, we use the same idea. We use the pie chart idea.
Right.
I mean, we have consistency between what's going on. And whatever the auto scaling is that deals with, who gets what piece of the pie type thing works the same way. And then this idea, using this notion seems like an ideal thing to do. I mean, I don't know what the language of annotations is here. I'm okay. So you've got specific thing here. I think that could be fancier, but doesn't matter. I mean, that would be a good start. And I think you've already got something like this here, which is fine. I mean, that seems like, so then what happens is it's graph value plot of the graph, then the information on what values you're picking up, and then the information on how you're rendering those.
Right.
And you're not entangling those things together. So in other words, and I don't know what you do for vector valued things here, but in other words, what you do is that thing at the end, the what you do with it thing, I don't know how let's imagine that it was this, that you could say size color, okay? And that what you were picking up for everything was a vector, 6, 4 or something. Then the first element of the vector will be size encoded, the second element will be color encoded. Is that sensible?
I think so. We're gonna have to implement and
Fine.
reason
Okay.
through and all that.
Right. But this is going to be good. Plot theme, small arc black. What's that?
Oh, if you open the example, it was an example you sent. If you go at the bottom, the last example, that one. It's called small arc. Sorry, forget about the black.
What does it mean?
So if you remember, essentially the S-shape function are, instead of drawing straight line, we are drawing small arc. So that's why we call the plot team small arc. And this example was coming from your NCAS book.
I know. I did this by hand. I mean, obviously in the book, those arc outwards. Why does that arc inwards?
Yeah, we can fix that.
Yep. Yeah. I mean, I think it should always puff out, shouldn't it?
Doesn't it need to, like some of them seem to need to arc in different directions too, no?
Yeah, they do, like this one here.
Right.
Right.
But when there's single one, we can take the outer one.
But I mean, this idea that everything is an arc, I think is a good thing. I think it makes graphs look really nice. And I think that should be generally the default. And it is generally the default, isn't it?
No.
No.
Well, many graphs that I draw have non-straight edges, which I like very much. Right? And what's happening, but occasionally I get ones that just have straight edges. Why?
Well, I'm not sure the case you're talking about. It's possible that when you are probably using layer graph embedding, where we generate those curve one, right? And if you modify the graph, we switch the layout, and then we don't have the same routing anymore.
Okay, but that's what I'm saying I don't like. I mean, when it goes all straight, it looks very coarse. Right. Can I suggest that we move that discussion to the graphics improvement meeting, that we talk about this there? Can somebody please add that? The stratification or non-stratification of edges.
Yes, I'm taking.
Carla, please.
Yes, I'm taking the notes.
Oh, these are different highlights.
Yeah.
Those are nice. Those are very nice. As long as people know to use them. Okay. Highlight style. Okay, that's those. I thought we had, oh yeah, this is include outer face or don't. Is it obviously right to give the outer face first rather than last?
If you think of it as a polygon, yes.
What?
Why?
Because you think of a polygon having holes.
I see.
Okay.
It's a little weird when you include include outer face drops the first element, but if you think that's right, I don't quite understand.
I don't have 100%. I'm not 100% sure, Stephen. I'm just that's one.
Why are you saying that with respect to the polygon? Because it seems to me that when you're giving.
So
I
the
mean,
way in Geo and others think of polygons is like an outer circumference, and
Yes.
then there's inner
Right.
poles, circumferences. And the interfaces are kind of like that.
Right.
and I mean, for us, it was essential the ability to know the position and drop it if you don't need it, right? So,
What do you mean? So, oh, yeah, right, right. Well, I agree with both those things. That's nice. Curved edge thing looks nice. Well, wait. Where's the tag nest graph? Oh, there. I mean, the default should be colors, right?
right. So we are still working on you see, there is no tagged edge style. So that as soon as we add that, it will propagate the color appropriately.
Okay, and you're going to make decent colors for this, right?
Yes.
I mean, that's fine. I've used these zillions of times. It's useful.
I'm going to have to run. Sorry.
Okay, well, then let's wrap it up. Okay, we're going to have to continue this meeting. I'm not sure
Obviously.
exactly when.
Okay.
All right, see you guys soon.